This video explains how to use Archimedes to perform Wilcoxon Rank Sum tests, especially for testing general hypothesis statement like the difference between two means is equal to a specific value. Now, most of the statistical software usually is designed to test for whether there is a difference between two means. So this delta is 0, that difference is 0. Now, if in case this data is not 0, then when you calculate the Wilcoxon Rank Sum Test, you will use the sum of ranks of xi minus data 0. xi's are all the values observed from first sample or the smaller sample. Let's look at this example. Here we're doing a two-independent sample test. We have two samples. The smaller sample has these 4 observations, and the larger sample 2 has this 5 observations. And if we wish to test whether the difference between two means is equal to a specific value, here is 0.5. Then when we set up xi, right, the observation for the first sample, we have to actually subtract each of these values from first sample by 0.5, which is this test value. If this is 0, then we can just use the first sample observation. But if this is not 0, all the observations in the first sample have to subtract that test value. So after you've done that, okay, so the first sample, we have this new set of observation. Then we apply the Wilcoxon Rank Sum Test for testing difference between two means, but this time actually would be the mean of the transformed data. Okay, so when you assign rank from the smallest to largest value, this would be a new ranking. And what's a test statistic? Rank sum test statistic is sum of the smaller samples, so it'll be the sum of these 4. So when you actually perform the test, the W test statistic is sum of these 4. Right? These are the after shifted 0.5 and the rank sum of the first sample. So if you run the Wilcoxon Rank Sum Test, you're going to get a test statistic 20. Now Wilcoxon Rank Sum Test statistic produced by Archimedes is slightly different from the rank sum test we define. The W in R is actually the Wilcoxon Rank Sum Test minus the M times n plus 1 over 2. The M is a sample size for the smaller sample. The Wilcoxon Rank Sum Test, subtract this value, the M is 4. 4 times 5 is 25 by 2, which is 10. And 30 minus 10 is 20. That's how Wilcoxon Rank Sum Test give you the 20. So if you use Wilcoxon Rank Sum Test from Archimedes, that rank sum is slightly different from this. Okay, so if in case you get 20, if you wish to get the actual rank sum from the statistic that I defined here, then you will use 20 plus this m times n plus 1 over 2, so you get 30. There are different versions of this rank sum test. Regardless of using the Wilcoxon Rank Sum Test from Archimedes or Wilcoxon Rank Sum Test from what I define, if you use a sampling distribution under each of these different situations, it will all produce the same p-value, which is 0.02587, right?
So to use Archimedes to solve this problem, first of all, you have to enter these data, right? So these are new data. I'll just subtract 0.5 for the first sample, and these are the second sample, and I'll use these 1 and 2 to indicate different sample. Small sample is 1, okay. Group identification is 1. Then of course you want to set this as a factor variable, okay. And to run the Archimedes, you click statistic, non-parametric. Now if you didn't set the group variable as factor, your two-independent sample test is not going to work. Right? So you click data, transfer and data set, and then convert. And actually my V2 is the group variable, so I'm going to use the actual value as the values and set them as factors. So I click OK. Okay. So if you look at the data, okay, they're still the same, but now the V2 becomes factor variable. Okay, so I can run statistic non-parametric, a two-sample Wilcoxon test, and then they're all ranged properly, right? The group variable is the V2, an option, the software only allow you to actually test the difference if zero or not, right? So we did the right thing. We did a transformation first for the first sample. Okay, so I'm going to click OK, and you get the result. Right, you get the p-value. And of course, this is the rank sum test statistic from the R Commander software. Right? Now, if you use a rank sum statistic that I define, you're going to get 30, and you know why they're different. Okay? You know, idea behind this making the rank sum the sum of ranks of xi minus the delta 0 is that if we try to use a test only for testing difference between two means, then we can transform these hypotheses to mu1 minus delta 0 equal to mu2. So whether there's a difference between mean over here and the mean here. So if you have a software that is only good for testing difference between two means, this transformation can help us to achieve the goal for testing hypotheses like this.